Hey everyone, so I don't know if you heard, but this new title of Full Stack Data Scientist has been growing in popularity. To that end, I'm making a video here on an end-to-end project running through the full data science lifecycle in AWS. Now, if you don't know who I am, my name is Ravi. I am a freelance ML engineer. I've been in the data and AI field for over 5 years after studying physics. And I'm just getting started on YouTube, so definitely follow more for stuff like this. But getting back into this video, so if you don't know what full stack data scientist means, it just means being able to do a bit of data engineering and data analytics and science, and then ML engineering and ML ops engineering. So those are the 5 different main titles in data science. And to be full stack means to be able to do all of it. Now, an end-to-end project typically means you kind of will go through that process. Sometimes it might just mean an in-depth end-to-end project in one of those specific areas, but anyway, in this case, what I'm going to do is I took a data set that's relatively clean already. It is on gaming behavior. So the goal is to predict a gamer's engagement level, low, medium, or high. I'm not going to go through the exploration of the data because it's already clean, and I do have a notebook where I did do that, so I'll link the GitHub repo in the description so you can check that out. But yeah, so the main point is to go through or to show you what the code looks like for deploying everything in AWS. And as far as the data science lifecycle is concerned, I'm going to do an ETL job with the AWS Glue here. So I guess you could say that's the data engineering side. And then I'll do some data science side in, I guess, kind of MLOps where I'm going to put it in AWS. So we'll run through a pre-processing step, a training step, and then I'll leave it there for now, but I will test the model at the end locally as well. Okay, so that's it. That's how this is going to go. Before we get started, you do need to set up AWS if you don't. So I do have a bullet points. There's quite a few to get started with AWS. Let me just run through that. This notebook, by the way, is also essentially a blog post that I posted on Medium, so I'll link that below as well, so you can get links to everything here easily. Okay, and by the way, also the dataset comes from Kaggle, so pick that up as well. But yeah, so first things first, you need to download the AWS command line interface. So I'll just click that link, follow the steps and download. Then you also do need to make an AWS account. Hopefully you already have one, but regardless, the point is that you're going to go into your AWS account. Let me do that right now. Okay, I'll just go back to the home. And then you're going to create an IAM role or an IAM user. So just go to users. So you'll be in your admin account. If you don't know, in AWS, you have your admin account. And you can also log in with your IAM user. Right now, I am already logged into the IAM user, so but I'm just going to show you how to do that right here. Just as a brief overview. So yeah, so create a user when you're there. Create a different one. These are the users I have. This is the one that we're using right now. Okay, and then next, so yeah, once you click on it, go to security credentials and create an access key. And then once you do that, you're going to get an access key and a secret access key. Make sure to save those. Alright, and then, okay, so we can do this now. Actually, open up command prompt. I use Anaconda prompt, so type in AWS configure, and then it will ask you for those access keys. Let me just shout out real quick. You can also, when you set up access locally to AWS, you can input your access keys as arguments here as well. So I didn't do that, but here, this is just an example of one place where you can do that. So if you want to do it this way, that's up to you. Or you can just type in AWS configure. It'll ask you for them there, and that's fine as well. Or do both, I guess. If you do AWS configure, it'll ask you for a couple other things. Just hit enter, leave them blank. You don't need to worry about them. Okay, next is, alright, go to the permissions section. Let me do that. So do that. So go here. You have two options. One is give yourself access to SageMaker, Amazon Glue, and Amazon S3. So that's what I did here. Or you can be lazy, since this is just a practice project, and give yourself full admin access when you're in your admin account. It's up to you which one you want to do. Doesn't really matter if you're just practicing. But yeah, that's it. So like I said, that you're probably in your admin account. Log out of that, and then you're actually going to go back into the sign-in part of AWS and log back in with your IAM username. Okay. And yeah, I think that's it. So once you do that, go back here, click on roles. What you want to do is go, so I have this here, I have them here, just copy and paste these. Just one sec. So just copy that, type that in here, click on this, and this is what you need. Amazon resource number, save that. What you should do is create a .env file in your root directory and save it there. Okay, and then do the same thing with the Amazon SageMaker execution role. Right, okay, and then I mentioned the last step is that .env file. That's where you put your environment variables, like those things there. Also put your bucket name. Alright, so let me just do this real quick. Right, okay, I did mention it here. Go to S3 in your AWS account. Create a bucket. I already have a bucket. This is the get bucket that I used. So what you should do is create a folder, and then in the folder, then you can click on the upload button. That's where you put your Kaggle dataset, which would be a .csv file in this case. And then your bucket name is this. You can save that in your .env file as well. Now, with all that done, now we can actually get into the code. Okay, so if you see here, I ran this notebook in a notebooks folder, so I went back to the root directory. So I would do that if you're following along. The other thing I did to follow MLOps best practices is to follow that typical code structure. This is super basic, but in this case I have ETL folder, modeling folder, pre-processing folder. Before we do create those, right now what I'm doing here is I'm just creating the SOC folder here, which is the source code. Okay, and then I'm loading the env variables that I told you to save. And now here, this is where I'm creating the ETL folder. And this line is Python magic. So what this is going to do is create a script.py file. And in that .py file is going to be all of this code. And the place it's going to go is in that ETL folder. So let's just see that. So let's open this, and there you go. That's where all the code is. Okay, so that's it. And I'm not going to run through each line by line. A lot of this is actually standard code you'll see in AWS Glue jobs. You can find that in the docs, or probably ask ChatGPT for it. But yeah, that's fine. Just take that, and then what you'll modify is these steps here. So what you're going to do is load in your raw data. That's what we're doing here. And then in this case, engagement level is a target variable. So I did label and code it. I did make some changes here. You can go through this if you want. Look at the exploration notebook. I don't want to spend time on this typical data science stuff. But yeah, that's all I'm doing here is just data transformation here. Okay, so so we're extracting, transforming, and then we're going to load it back into S3. So ETL job all done all in one. Pretty simple. But yeah, so we're gonna do this in AWS Glue. So that's what it's usually known for, doing more complicated ETL scripts. But yeah, so after that, now that we have our script, we're gonna like send it to AWS Glue. So you can see your script uploaded. So we're gonna upload that script to Glue and then run it. So here we're just defining the Glue job. So like glue client create job. That's what we're doing here. And here we have input key, which I defined above here. So that's just your bucket. Or no, your input key is where the raw data is. So that's your. So you should have created a folder called raw data and stored your .csv file in there. And then the input bucket is your bucket that we created. If you want to put it in a different bucket, I guess you can, but we're going to save it in the same bucket here. And then the output key is a different folder that we're going to create, transform data. And then I would also change the name. I mean, obviously don't just call it that. I guess you could, but I wouldn't. So just put transformed or something in front of it. And then that's your new data. And that's pretty much the important thing. Yeah, that's the important thing there. You can look at the other code and the other parts of the code, change it if you need to. But the other thing is that, so when we did this, we uploaded that script to AWS Glue, but it didn't run. If you actually want to run it, this is what we're going to do here. So, or it's this line right here. So this is going to start job run. And that will actually run the script in AWS. It will run through those processing steps and the transformation steps that we define in the script, and then save it in S3. Why don't we just take a quick look at that, actually. So, yeah, transform data, transformed online gaming behavior data set. So there you go. So that's it. That's the Glue job. Now we're going to tackle SageMaker. So, like I said before, this data set is already pretty clean. We didn't really need to do a whole lot. So right now what we're going to do is run through pre-processing, and basically you're going to see it. It might seem a bit redundant to do this and the transformations above. That's just because the data is already like so nice. Obviously that's not going to be the case. Typically pre-processing means prepping your data to be fed into a model, not necessarily just cleaning. And so you would have some separate steps there. So, but I just wanted to highlight AWS Glue here just to get you started with that. So that's why I did most of the steps there. But you can change them as you like. And again, a lot of this is a bit standard, so I will explain this later, so ignore that. This is just a SageMaker session and a pipeline session. Get your SageMaker client here. So I'm pretty sure in this case here, if you wanted to put your AWS access keys, you could define them here as well. Okay, but other than that, this right here, so we're going to create that pre-processing folder, and then we're going to put our script in there again, just like before. So let me just say, like I said, no real cleaning here. I did leave player ID when we transform the data. We're not going to put that in the model because that's like an index column. So drop that, and then we're going to split our data actually. And I think that's it. Split the data, put them in Y-train, Y-test, X-train, X-test, and then save them. And then let me just show, okay, so save splits, I actually did put them back together though. So you can modify that. Maybe there's some unnecessary steps here, but yeah, so we have just an X train or a train set and a test set. Okay, so and then we're saving that. So let me just so scrolling down here, we have our so we're going to processor. So this is just defining some attributes for our processing step. So let me just say this is the instance that we're using. I will recommend that you use ml.m5 to xlarge. It is fast, but it's by default you don't have access to it. You can just go in and request to have like 4, I think just request like 4 instances and it'll give you it in like a day, so it'll be noticeably faster if you do that. You don't have to though, so it's fine if you don't want to. But yeah, otherwise we already defined these above, so that's fine. Just leave that as is. And then here's the processing step. We're going to define this with our script that we have in our folder. This right here is standard for SageMaker, so don't change that. Same thing for this. This you can change if you want. Same thing for the output name and output name here. But yeah, so the outputs are the train and test set, and we are going to save them in a new folder called preprocessing. Alright, so we'll have different folders for each of them. Okay, and then next thing is actually defining the pipeline. So a pipeline is just a sequence of steps, really. In this case, we just have the one because it's the first one in SageMaker. So yeah, nothing really too interesting here. And again, like glue, this line here just puts the script into AWS but doesn't run it. If you want to run the job, this will do it for you. So only hit to run this if you want to run it, obviously. And if you do that, this is what you should see in your SageMaker. So let me go to SageMaker. I'll do it manually again. So let's just, okay, so Amazon SageMaker, I have it right in the front. Alright, go to Studio. Open Studio. Go to Pipelines. And then right here. Or whatever you called it, you'll see it there. But this is what you'll see. Okay. Now, next thing is actually the same thing except for model, or for modeling. So create that folder and put the file in here. This is the entire file here. So for the model, I did do grid search outside of this in that exploration notebook. So these are, I already know what good ones here, or what the good values here are. But yeah, otherwise I'm just getting the X train and Y training data and the testing data and just training the model, predicting and getting accuracy scores. If you don't know what the Cohen kappa score is, it's a harsh metric. It's pretty good for multi-classification tasks. So you can I use that here if you want. It's pretty harsh, like I said, and in this case, it actually did pretty well still. So that's how you know this data set is a little too good. But anyways, yeah, so I do just print the evaluation scores. Oh, this is a mistake. Accuracy score. Ideally, you would log these and save them, but that's a problem for another time, I suppose. So I'm just going to save the model path at the end of this, and then over here I'm actually saving the model. So I'm going to go back to SageMaker, or not SageMaker, let me go back to S3, go back to our bucket, scanning behavior, and then right here, this is where it's going to be output model.tar.gz. Okay, so that's going to contain your model. And then as for deploying this to AWS SageMaker, we have a similar thing as to the pre-processing step. So here's our estimated, this is the XGBoost specific one that SageMaker has. But yeah, just define your hyperparameters here. I did switch to that xml.m5.xlarge, and everything else I think is straightforward. I just want to shout this out. So this is actually SageMaker specific, so don't change that. You will need this for your model directory. And then same thing for these two. So yeah, just don't mess with those too much. Okay, and then yeah, so this I'm just defining the I'm creating the training step, and you can see we have training input, and so the training input is the train set and test set. We don't have an output here. Now I did have to comment this out. I wanted to mention what this was. So let me go back to SageMaker, or hold on, let me just say, so here's a pipeline. Now we actually have two steps. So our pre-processing step and the training model step. Then we'll push that to AWS and run that pipeline. And now this is what you'll see. So that cache config thing that I always wanted to mention. Let's say your pre-process data runs and your train model fails. This will be red if that's the case. If you run it again, like let's say you train the script and you train the model and you try running it again, there's no point in running this again, right? So cache will actually just take the output of this and just like continue from there. So you don't need to run through this again, because that might take some time. But yeah, so this is kind of a long video, but that is actually it. So for now, yeah, so just to show you everything worked, let's test things out locally. After this, there's still a lot you could do. I think the most obvious thing is to deploy the model. But yeah, I just want to test it locally since this is already pretty long. I'll probably do a different video completely on like model deployment and more MLOps stuff. But yeah, so load in some of these, and then just to be consistent here, I want to load our model from S3. So let's load the data from S3 as well. And that's good too, because we don't want to run through the pre-processing steps locally. So we'll load that testing set. Okay, so that's why I'm going to get this right here. So, and by the way, the file key. So let me just go back to S3. Go to gaming behavior. Go to, I think this one. Yeah, go to test folder, test.csv. Copy S3 URI. Go click on that. Let me show you this, and then, okay, so you see this is the S3 URI. So this pre-processing test.csv, that's where you can get this. Okay, so literally everything after the bucket name. Okay, so that's what you'll need. And then we already have the bucket name. We did put that in a .env file, if you remember. So, yeah. That's fine. So load in our data frame, and then remember for the test set, I did put the photography variable back into it. So here I'm just dropping it, creating a sample of the first row, and then here's multiple samples. Okay, so I call this object key here, I guess, but this is the same thing. Get the S3 URI for your model.tar file. So this is what it should look like, something like this, just this will be different. And then to create a local folder for, call it whatever you want. I called it local model directory. Okay, and then model, and then I loaded everything in here from S3. And then we're going to actually extract that. And what's going to happen is we're going to get, let me show you. So we're going to get these files here. Okay. Now, SageMaker's latest version of XGBoost is, I think, 1.7. So just to make sure this works, load in or use xgb.booster. This is like an empty xgboost object. And then those parameters for xgboost, you're going to load that into this by doing model.load model, and then game behavior model is what I have here. And that name you define in the model training script. So let's see if we can find that. Yeah, so this is what we defined it as. Arc name, game behavior model, okay? And I think that's it. So we load the model with that, and then yeah, so in this case we need to convert our samples to a D matrix before we put it in for predictions. But otherwise, yeah, we'll get this. Just remember, we do get probability distributions with XGBoost. So take the argmax there, but otherwise, yeah, that's it. We've made predictions with XGBoost locally, and we did this by running through everything in AWS. So we extracted the data, raw data in an S3 bucket, put it back in the bucket, transformed, then we pre-processed it, put those transformed versions as training and testing sets in S3 once again. Then we took that data, trained the model, saved that model in S3, and now we loaded it locally to test out. The nice thing about loading it locally is that I think you can like test it out in like a Flask app, so I think that's something I did before, so yeah, and then you can deploy that Flask app separately in AWS in an EC2 instance if you want. But yeah, that's it. I think the other natural, I don't know if I mentioned this, the other natural next step would be to deploy the model as an endpoint. That can be costly though, so that's why I didn't cover that here. It actually won't be if you delete it. If you just run it as an endpoint, and then delete it as soon as you're done, you won't lose any money. But yeah, just don't. If you try that, just don't leave it running. But yeah, that's it. AWS end-to-end, almost end-to-end project. The only thing missing is MLOps stuff. So sub for more like this, and I'll cover some more MLOps later after this. But yeah, that's it. See you next time.